Hello, today we'll be talking about writing equations of piecewise functions. Given a graph, I can write the equation for a piecewise function. That's our learning target for today. Some useful tools to use when working with piecewise functions. Writing domain for pieces of graphs. The first notation we've seen is some sort of inequality, like all x's that are greater than or equal to 7, or if it's a range of x's between two numbers. For example, x is between -3 inclusive, so that'd be a filled in circle, and +8, and that's an exclusive inequality. So that would be an open circle at 8. The other way would be an interval notation. For example, -∞ to 9 inclusive, so there'd be a closed circle at 9. Or if it was between two values, like -4 and 5, and those would have open circles on that piece. The next useful tool, remembering equations of horizontal and vertical lines. If x is some number, that is our vertical line. If y is some number, that's our horizontal line. And we have some general forms for common translated functions. The first would be a linear function. We're more used to slope-intercept form, but we also have this linear translated form. In this form, h comma k is some ordered pair, x comma y. M is still our slope. And we'll use this today. Sometimes the projection of the y-intercept for one of the pieces could be well off our graph, so we don't know exactly what the y-intercept would be. So it'll be more useful to use that translated form in order to find what the function for that piece is going to be. And you'll see that in the examples today. And one other common function to keep in mind is our absolute value function, y equals a absolute value x minus h plus k. Remembering if a is negative, it flips it upside down. A acts as sort of our slope for the absolute value function. H moves the function, the vertex left and right. That's h. And k moves our vertex up and down. So let's say, for example, we want to write the piecewise function given this graph. Notice we have two pieces. Okay, we have this, and I'll just call it the blue piece, and we have this red piece. Both of these are linear functions, so we're going to practice using that linear translated form in order to write each piece of the graph. And to do that, we're going to start with our piecewise function notation, and I'm going to kind of make a rough draft. We'll just call this our scratch work. Okay, we're going to need to show a little bit of work in order to find our pieces. So I'm going to do a scratch work first, and then I'll make a final draft of our function at the bottom. So looking at the blue piece, I have my f of x equals, okay, I'm going to choose some point on the graph to find the slope between the points and to fill in my linear translated form. Remember my translated form, y equals m parenthesis x minus h plus k. I'm going to choose, go right here, I want this to be my h comma k. So that's 1 comma 2. We've got h and k. Filling in my translated form. The slope between those 2 points is down 1 over 1. So I have a slope of -1, parenthesis x minus, h is 1 from my ordered pair, plus k. And that's how we use our translated form. We just choose a point, h comma k on the graph, it's x comma y, and fill in our translated form using slope, h, and k. Now that's a perfectly acceptable solution, but some of us like to see slope-intercept as well, just to make sure that we have it correct. So when I distribute my -1, I'm going to go down to my final draft here, I get -1x or negative x, and then -1 times -1 is +1, and I have another +2 at the end, so that leaves me with +3. And if I look at my blue portion of my graph, my y-intercept is at +3. So I know I did the translated form correct. The last thing for a piecewise function is to write down the interval of that piecewise function. Okay. Well, it's from -infinity to +2 on the x. Another way to write that in our inequality notation would be that the piece is all x's that are less than or equal to 2. For the red graph, okay, notice that if I project this upward, okay, it will eventually cross the x-axis, but I want to be sure where that's going to be. So I'm going to use that translated form. Let's choose a point again for my h and k. That is 3, -3. So for translated form, the slope between those 2 points is down 2 over 1, so it's -2. Parenthesis x minus h plus k, and k is negative, so I subtract. When I distribute and combine my like terms, I get -2x plus 6 minus 3 leaves me with +3. Going back to the graph, okay, if I project that out, it looks like it will cross around +3. So that's going to be our solution. And let's write the interval. There is an open circle at the x value of 2, and it includes all x's greater than that x value. So that's going to be all x's that are strictly greater than 2 because I have that open circle. Example 2. I've got 3 pieces. I'll do the first one in red. We can do our second one in green here, and we'll keep that last one in blue. So I've got 2 linear functions, and I've also got a horizontal line here. So let's look at our first piece of this piecewise function. It's linear, so let's use that translated form. Y equals m. Well, I need to find the slope. Okay. Well, let's choose another point, hk, that is on one of the corners of those grid lines. Okay. The slope between that point and the open circle is down 1 over 2. So my slope is going to be -1/2, parenthesis x minus, and then I've got my h comma k. Well, that's going to be -3, I have to count there, -3, comma 0. Okay, well, that's again my h and my k in the translated form. H is always x, and k is the y piece of that ordered pair. So filling in the h minus a negative h gives me +3, and my k is 0, so I have +0. Let's write our final draft. When I distribute, I get -1/2 x. Multiplying a fraction times a constant, just put the constant over 1, multiply straight across. It's going to be a -3/2, and +0 doesn't change that last constant. The interval of that piece is from -infinity to, this is -1 on the x-axis. So that is all x's that are strictly less than -1 because I have that open circle. For my second piece in green, Again, we said that's a horizontal line crossing the y-axis at positive 2. So on that interval, my solution is always 2. So there's no other work to be done there. Let's go to our final draft and write our interval. That starts at -1. There's a closed circle there, and it's all x's between that value, and it looks like a positive 3. And there's another closed circle, so we're going to have that equals under the inequality symbol there. And our last piece, we'll do that one in blue. Let's choose an order pair HK, 5, 2. Again, that's H and K in the linear translated form. So that's my last piece. So y equals m. Well, my slope looks like it's going down 1 over 1, down 1 over 1. So it's going to be my slope, -1. Parenthesis x minus h plus k. When I distribute, let's go to our final draft. I get -1x or negative x. -1 times a -5 is +5, and I have another +2, so my solution is +7. That interval started at a positive 3, and it's an open circle, so that is all x's that are greater than a positive 3. Our last example, I've got a blue line, I've got a red line, another horizontal line, so that's kind of nice, and a purple line here. Starting with our blue line, let's recall what those v functions are called. Those are absolute value. Okay, we need to figure out where that vertex has moved from the parent function, and then see what that kind of slope looks like. Okay, so filling in my absolute value. Okay, this is my vertex. From this point to this other blue point, I'm going up. Okay, so I know my a value for the absolute value is not going to be negative. It's going to be positive. I'm going up to right 1. So we call it a slope. It's not technically a slope, but it kind of acts like a slope. Okay, is going to be 2. Then filling in the rest of my, oops, that's an absolute value bar. Okay, filling in the rest of my absolute value, I write an x. Okay, the h is my left and right. I went left 3. That's +3 on the inside of the absolute value. The up and down, my k value from the parent function, from the origin, I've gone up 2 units. So my k value has to be +2. And there's no other work to show there, so I'm going to go to my final draft here. You don't always have to do a rough draft and a final draft. I just like to, for those longer linear functions, the translated when you're solving, it gets a little hectic, so I like to have just a little bit of workspace before I write my final solution. So again, 2 absolute value x plus 3 plus 2 is the blue line, and that's from all the way to the left to a -2 on the x-axis. So that is all x's that are less than or equal to -2. The red line, horizontal line, okay, is the line y equals a number at its y-intercept. That's right here at a +4. So on that interval, my solution is always 4. Let's write that interval. Okay, it's from -2 to a +3. There are closed circles there. So from -2, inclusive, x, inclusive, less than or equal to 3. Now you're wondering, well, what about the value of -2? What function do I use when it's -2? If you plug it in, if you plug -2 in right here, okay, -2 plus 3 is 1. The absolute value of 1 is 1. If I multiply that times 2, I get 2. Plus 2 is 4. Okay, look at the red function. If it's -2, my output is 4. So it's the same answer for both of those. That's why it doesn't matter which function we're going to use if x is -2. Okay, I'm going to erase those pieces. We don't need those. I was just showing you that it's okay for the same value, -2, to be included on two different functions. It gives me the same answer. Okay. And our last piece, notice if I project this slope in the opposite direction, this ends up way off the graph. Okay. So that's why we're going to use this translated form. You have to here. Okay. We don't have a choice. So let's choose an h comma k. I'm going to go 4 comma 1. 4 comma 1. I can choose any h comma k that I want. Remember h is x and k is my y. So the slope between those 2 points, notice I didn't choose a point that's not on the corner of one of our grid lines or one of our grid boxes, because that doesn't tell me the slope, and that's going to be a nasty number. So I chose a value that's right on the corner there, 4 comma 1. The slope between those is down 3 over 1. It's -3. Filling out the rest of my translated form, x minus h plus k. Let's simplify that. -3 times x is -3x. -3 times a -4 is plus 12, and I still have a plus 1 at the end, so that would be plus 13. Telling me that my y-intercept way up here would eventually be a positive 13, and we wouldn't have known that if we didn't use translated form. The last piece is to write our interval. Started at +3, and it's everything greater. So my x is greater than or equal to 3.